Good afternoon, everyone. The topic for today's class is Mechanism of Action of Fluorides. The contents are Introduction, Mechanism of Action of Fluoride, and the Preferences. Introduction. Fluorine is the most electronegative element and therefore highly reactive. It does not occur in the elemental state in nature but is widespread in nature, occurring in fresh water, vegetables, blood, milk, and organic compounds. Since fluoride can affect both the inorganic structure and the bacterial metabolism in the plaque, several mechanisms of actions have been proposed. Reduced enamel solubility, improved crystallinity, promotion of remineralization, lower free surface energy, desorption of protein and bacteria, reduced karyogenic flora, and inhibition of bacterial enzyme systems. Many of these mechanisms probably work simultaneously depending on the concentration and form of fluoride, but the exact contribution of any one of the total caries reduction is unknown. Coming to the element fluorine, it is a trace element, member of the halogen family having atomic number 9 and atomic weight 90. The rich sources are the dried fish and tea. It is present in rock and soils in the form of fluorspar, fluorapatite, and cryolite. Additional fluoride distribution is found in atmosphere, soils, gaseous industrial waste, and gases emitted in volcanic areas. The mode of administration of fluorides is two. First is systemic fluorides and second is topical fluorides. Systemic fluorides includes water fluoridation, milk fluoridation, salt fluoridation, fluorides, tablets, drops, and lozenges. And in topical fluoride, it is of two types, professionally applied and self-applied. For professionally applied, we have the fluoride containing prophylactic paste, solutions, gels, and varnishes. And self-applied includes the dentifrices, mouth rinses, and gels. Coming to the mechanism of action of fluoride. So there are mainly 5 points for this. It causes increase in enamel resistance or decreased solubility, increased rate of post-eruptive maturation, remineralization of the incipient lesions, interference with plaque microorganisms, and modification in the tooth morphology. So first is increasing the enamel resistance. The fluoride ions fill the inherent voids due to the missing hydroxyl group in the hydroxyapatite crystals forming fluorapatite. Fluorapatite is more resistant to acid solubility than hydroxyapatite. Fluoride ions add their hydrogen bonding tendency to the forces which hold the crystals together. This stabilizes the apatite crystal further. The void in the crystal decreases the stability and increases the chemical reactivity. If the fluoride fills these voids in the hydroxyapatite crystals, they will attain stable form with the formation of more and stronger hydrogen bonds. So this is the diagram showing the formation of the fluorapatite in the enamel. So greater stability will lead to lower solubility and hence greater resistance to the dissolution in acids. Enamel, which mineralizes under the influence of fluoride, has a lower carbonate content, thus giving reduced solubility. Second is increased rate of maturation. The resistance of the teeth to caries appears to increase with post-eruptive age. Newly erupted enamel has areas where the mineral deposition is not entirely complete. Hence, newly erupted enamel is able to acquire more fluoride than the older enamel. The presence of fluoride increases the rate of mineralization of the hypomineralized areas. The hypomineralized areas which mature in the presence of fluoride contain more fluoride than enamel, which has been fully mineralized upon eruption. These areas will therefore be made more resistant to acid attack. So next is the remineralization of the incipient lesions. The minerals of the tooth enamel are continuously in exchange with the minerals of saliva and thus the balance is maintained. This equilibrium can get disturbed with the organic acid produced by the metabolism of the fermentable carbohydrates by the microorganisms, which leads to the drop in pH of the plaque on the enamel surface and the subsurface. Minerals, particularly calcium and phosphate, leave the dissolved enamel in their ionic form and enter the plaque fluid. So this is the diagram where the red circle you can see this is the area of the hypomineralized area. So what happens that whenever the fluoride is being given, it will cause the remineralization. As we know that the remineralization and demineralization is a continuous process, and there are areas of the whenever caries is there, it gets affected up to the dentinal layer. So we have the areas of infected dentine and affected dentine. The infected dentine has to be removed and affected has to be preserved. So when fluoride is given to the incipient lesions, it will cause the remineralization of these lesions. This process we can see is called demineralization. An early clinical stage of dental caries which appears as white spot lesion causes incipient lesion of enamel. So presence of 1 ppm of fluoride can cause remineralization of these white incipient lesions. So this is the diagram. We can see that we have the tooth enamel over which there is a layer of plaque and the surrounding is the saliva. So it is a continuous demineralization remineralization cycle. Whenever the plaque pH decreases below the critical level, demineralization will occur. And when we give the fluoride, so it will help in the remineralization of the lesions. So this is the diagram. We can see how the process of the mineralization of the tooth structures takes place with the help of the fluorides, where the plaque reservoirs will be there, where calcium will be there, fluoride will be there, in the saliva also fluoride ions will be there, which will be injected into the plaque and then into the tooth structure, the enamel of the tooth. Next is the interference with the plaque or the microorganisms. The fluoride, it interferes with the metabolism of microorganisms involved in the caries formation. The enzymes most sensitive to fluoride during the formation of acid is enolase, and in the formation of polysaccharides is phosphoglucomutase. Fluoride acts on enolase enzyme and thus prevents the conversion of glucose to lactic acid. So this is how we see that the organism which cause the caries, the most potent group of organisms are the Streptococcus mutans, which causes the initiation of caries. Other than that, we have lactobacillus, which causes the progression of caries, and actinomyces, which causes the root caries. So the Streptococcus mutans, which are the most potent group of organism, produces certain enzymes, which is the dextrans and the leucans, which causes the cavity preparation. How they causes? Because these microorganism, they will cause the production of the acid. They will cause the fermentation of the dietary carbohydrates to produce the acid. And these acid will cause the dissolution of the inorganic and the organic matter of the tooth. So this is how the caries is being caused by the microorganism. Firstly, the microorganism, they will act on the carbohydrate or the sugar content. They will produce certain acid, and these acid will in turn cause the cavity. So what happens when we give the fluorides and it is being injected? So it will interfere with the plaque microorganism. It will inhibit the enzyme enolase and it will inhibit the acid production. And since no acid production will be there, so less amount of the caries will be there. So it prevents the entry of glucose into the bacterial cells, and it also prevents the conversion of glucose into glycogen, which acts as a storehouse when glucose is not available. And last is the improved tooth morphology. So areas of the teeth more susceptible to dental caries are the occlusal surface, and those with deep fissures are considered to be more prone to the caries. So we can see in this diagram the pits and fissures are shown. That fissures are of different types, that is U, V, I, K and inverted Y. So U and V are the deep fissures which are more caries resistant, and I and K are the caries, they are caries susceptible lesions where are rare resistance because they are the self-cleansable areas. So fluoride, it is believed to alter the tooth morphology, that is it causes reduction in the cusp height, reduction in the fissure depth and increase in the fissure width. So teeth become more self-cleaning and less susceptible to caries. Certain self-cleansable areas have been there. So this was all about the mechanism of action of fluoride. So it acts in the 5 ways to prevent the caries. And these are the references which can be referred further for the further reading. Thank you.